Hello everybody and welcome back. Today I'd just like to make a video about how to use the TI-84 plus CE specifically for calculus. So I won't cover absolutely every function of the calculator, but I will cover everything you need up until BC. So now let's get into how we do some of our arithmetic functions. So supposing I wanted to write -2, I'd have to write -2, and suppose I wanted to add 3 plus 3, and then I could enter. But what if I want to alter my previous answer in some way? We have 1. Well, what if I want to get 1/2? Well, I could hit the divide button. I could enter 2. And that is how you alter your previous answer. Now, finally, just supposing that we want to change, or not change, but we want to use an answer in an arithmetic expression. Then what we can do is we could write something like 9 minus, scroll up, navigate upwards using these arrow buttons, and select 0.5, and enter again, and we will get 8.5. And that's really all you need to know for arithmetic. Now, if I just want to clear the screen, I can hit this clear button. But if I want to clear my history here, I'd go to the top, hit clear, clear, clear. And that's it. Now, supposing I want to write a fraction, what would I do? Well, first, we need to understand what these second and alpha buttons do. The second button essentially alters each button to its blue function. So suppose I see this x squared button and I want to write square root. I could hit second and x squared, and we will get a square root button. I can enter a number and then enter, and I will get 2. But this alpha button is for using all these green functions. So starting at this math button and working down, you really aren't going to use this because most of these buttons are just the alphabet and you can write words with them. But what you will use it for frequently is in this top row of buttons. You will often click alpha and then F1, and this will give you some fraction expressions. Then you can navigate to the right. Then you can apply something like absolute value, a sum, a derivative, a finite integral, etc., or a definite integral, I mean. You can navigate over. I've actually never used this column, so I don't think you want to need to use this for any of your math classes, I assume, unless you have some sort of special assignment. And then finally we have over here our functions. y1 being our first function, y2 being our second function, etc. So I can hit second mode to get out of that. And I think it's good to know that if you're ever in any sort of page and you're wondering how you can escape, you can hit clear sometimes. That'll work. But what will always work is hitting second mode, or at the very least, just turning your calculator off. And then when you turn it back on, it'll refresh to the home page. Now, getting into some algebra, let's try graphing a function. So first, in order to write a function, I need to hit this y equals button. Supposing I wanted to write something like x squared, I'd hit my variable button right here with x, t, theta, n. And right now we are in what is known as function mode, and I'll get to that later. So all of our variables will be x. And for calculus BC and below, you do not need to have a multivariable function. So don't worry about that. And then I'll hit the square button. Like that. Now we have x squared. Or supposing I wanted to do something a little fancier, right? I'm just going to navigate back, hit the delete button for the 2, hit the delete button again to get rid of the square. And now I can hit this arrow, which is to raise x to a power that could be anything, for example. So I could do 5, I could do 6, Or if I use that knowledge I just learned about this second button, I can hit second, and then I can hit the up arrow and I'll have x to the pi. So that's kind of cool. And then I can hit -2. And then to graph, I simply hit this graph button. All right, and now we have our graph. Now you'll notice, right, that on our graph, we can navigate using the arrows, and that the minimum x value we have here is -10, and the maximum x value we have here is 10. And that goes for the y's too. If we want to change what we're looking at right now, if we want to see, say, the graph still from -10 to 10 for x, but from -20 to 20 for y, we're going to hit this window button. And this window button will alter the appearance of the graph that you're looking at in this window. Now, the only buttons or the only functions here you need to worry about is this xmin, xmax, that would be your minimum and maximum value, and your ymin and ymax from here to here. So we could change this from -10 to -20, and this to 20. And then if we hit graph again, our calculator will regraph. But you can see we have these more frequent tick marks on our graph, which represents that we have more y values represented. So now I'm going to hit second mode, and this will just take us back to our home screen. And now supposing I want to evaluate our function at a point, what I can do is I can hit alpha y equals, taking us to F1, and navigate over, and then either hit enter because we're on y1, like here we're on y2, but here we're on y1, or I can just hit 1 because this is the first option and this is a 1. Or this is more fast. I can hit the alpha function and then hit trace. And what you'll notice is that we went to F1 there, but then we scooted over 1, 2, 3 times. So technically speaking, I could just hit this trace button, and that will take us straight to F4. I can hit 1, and then to evaluate it at a point, first I put my parentheses. These are the parentheses buttons, 1, and then put 2 or something, and then my other one, enter, and then that is 2 to the pi minus 2. And so that is how you just do those very basic algebraic functions. But what if I want to write a fraction, for example? What if I want to write y of 3 over 3, or y of 3 over 5, or y of 3 over y of 2? What I can do here is hit alpha in F1, and now we have this top option, n over d. This is really the only fraction function you need to use. I believe this option 2 is if you want to have like 5 and a half written out, where you have u equals 5 and a half written out. But I think that can be kind of confusing because then it might seem like you have 5 times 1/2. So for clarity's sake, I recommend using option 1. And now I can use that alpha, trace, y1 of 3, and then alpha, trace, y1 of 2. And now you'll notice right here that supposing I just enter this again, I didn't actually scroll up and hit this button right here. Because it wouldn't have gone underneath. If you remember before, I was doing stuff where I'd have like 6 minus, and then I could enter an old answer. You cannot do that unless you're using one of these arithmetic functions. So if you're using a fraction, you cannot do that or anything else. Now, before we move on, I think it's important to talk about the settings and where we can find those in this. So first, we have our mode button. And this is basically like our main settings screen. And we have some options that we can select. We have math, print, or classic. I actually am not sure what that does. You can leave it, it doesn't matter. And then we have a normal mode, scientific mode, and I'm not sure what that is. But just remember, this stuff really doesn't matter. What is important for your calculator is that you have it in radian mode, not degree mode. and that you have it in function mode, not parametric or polar. You will, even if you're dealing with polar coordinates or a parametric equation, it really isn't necessary, and it can actually make solving problems more difficult. And that's really about it. Those are the only settings you want to make sure you have in check. If any of your settings seem to be out of whack, then you can just reset your calculator on the back at this reset button. It's very faint, but right here, you can hold down on this button, and then a dark screen will appear on the other side. Once it does, what you can do is you can just turn on your calculator, clear your data, and you'll be good to go. Now, back to the video. So, suppose I want to do something related to calculus now. Supposing I wanted to take the derivative of our function at a certain point. What I can do then is I can hit this math button. And that is where you will find both the derivative and the integral. So derivative will be 8, integral will be 9. I don't remember just scrolling down like that, as I just showed you, because it takes time. Instead, you could just, supposing I go back, hit math, and then 8 for the derivative. Now we're asked, what are we taking the derivative with respect to? So I'm of course going to put x, then alpha, trace our function at x equals, let's say, 5. And that is our derivative. If I want to take the integral, for example, from 0 to 56 or something, and then I could plug in my function, dx, that's what I will get. And just for the record, on the AP test, or in your class, you only need to put the first 3 decimal places in an answer. And you can, on the AP test, you can either truncate or round. I'm not sure if your teacher has a preference for one or the either. I usually truncate because I just think it's simpler. But either way works on, like I said, the AP test. So now, moving on. Supposing I want to write a derivative function for this. I could just write out my own derivative of this function. I could write pi x to the pi minus 1. Or, if I'm being lazy, or if this is a complex function, which is more often the case, I can hit math 8, the derivative with respect to x of this first function for x equals x. So now if I want to evaluate this at any point, for example, I could hit second mode, and then I can hit alpha trace, hit 2 for y2, and then enter the derivative at any point. So up there we took it at x equals 5. Let's see if it's the same. And it is. Now we can also graph this though. So if you're not sure which function is which, you can hit trace and you will see what that function is at the top. And you can navigate from graph to graph by going up and down. So up, that gives us the derivative graph. And so if on a certain calculus problem you're asked to analyze where a certain function is concave down or concave up, you could substitute this derivative function like we have here into your calculator, and then you can determine where it has a negative slope and a positive slope. And when determining where it has a negative and a positive slope, you will also need to find where it has a slope equal to 0. So if we're trying to find the zeros of a function, are we trying to find an intersection point, or we're trying to find a value of x for which y equal, or a value of y for which x equals something, we can hit second calculator, and then now we have each of these options. So this is something I use quite often. I almost never use function number 6 or 7. But I often use number 5 if I'm asked, like, where is the derivative equal to something? Or I will use, and by the way, if I'm doing that with the intersection, I'd include 2 different functions where I have y equals that value and y equals the function. Then I have the maximum and minimum on an interval, and this is helpful, especially when doing EVT problems. Minimum value on an interval, a 0 of a function. Now this is really common, especially like I said, if you have the second derivative of a function actually, or whatever, then you might be able to find points of inflection that way, where they occur. So if I want to calculate this 0 just of the regular function, what I like to do is look at the y value, see when it's negative for my left bound, enter. See when it's positive, enter. And then for my guess, I just leave it where it is, enter, and then it will determine where the 0 occurs. And so that's really all you need to know for these functions. All of them work kind of the same. I could show you with the intersection point if you'd like. Actually, these graphs don't intersect anywhere. Let me try. So now I added y equals 1. So like now if we're asked to determine where is y equal to 1, I can hit alpha trace, or not alpha trace, oops, sorry. If I'm back in my graph, I can hit second trace. So I'm using the calc function. 5, intersect. And now it's going to ask, where do we think it occurs for the first curve? So I'd say like, I don't know, roughly there. Not exactly, but it's fine. And on this curve, I think like roughly there, I guess. And then it gives me the intersection. Now, I remember I mentioned polar coordinates and parametrics earlier, and I said that you will never ever need to set your calculator to polar mode or parametrics mode for a given AP test. So just making sure my calculator is in function mode. So I'm going to quit. And suppose I'm told that I have, suppose I'm told that there is a particle moving along a curve whose position is defined by x, comma 2x, where x is my x value, x of t, and this is my y of t value, which is really 2t. So imagine these are t's, right? Now, if we want to find the derivative at a point, we take the derivative of the y function, which would be this 2t, which shows up as 2x, but we're taking it with respect to x at x equals 1, divided by the other derivative at x equals 1. So let's just do that real quick so you can see what I mean. Math 8 for a derivative. Or actually, let me clear real quick because I'm going to do a fraction. Now, math 8, derivative with respect to x, alpha trace. Then my second y was my y of t function. So you see, now this is essentially the same as taking the derivative of y of t with respect to t, only we have x's instead of t's. And then we're going to take the derivative again, but with respect to t still, but then of x of t. Just making sure I said x comma 2x. That means x is our x of t, and 2t is our y of t. So going back, oh, I messed that up. So it's sometimes good to check to make sure you plugged in the right values. So let me just correct that. Trace y of 2. And I got 2. So that's just something you need to remember. You really don't need polar or parametrics mode. And yeah. Now, just a quick note, if you're writing a function and you wrote something you didn't mean to, like, say 1x, and you're just like, oh no, I forgot something, you can hit a delete function for this x, for example, and then it's gone. But if you want to replace it, there are no spaces between what we have written. Like, there's no space between 2 and this minus, meaning that if you're going to now rewrite that because you realize you actually do need it, then you're going to have to rewrite the rest of your function. You're going to have to write 2x minus 1x, or just minus x, same thing. So now let's just talk about, real quick, some of the other functions that we have on our calculator. We have ln of x. We have e to the x. So we actually have this right here, e to the blank, because it's such a common function and it shows up so much, like e to the x. Otherwise, you could just use second and then this divided symbol, and that'll also give you e, and then you can just raise it to whatever power. It's a little more roundabout, but it works. Then we have something to the -1. And just keep note that these x's aren't actual x's. All they represent is a given value you've entered. So 7, hit this button, that'll be 7 to the -1, which is 1/7. 1 over 7 is 0.1428 da 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 da. Now, our trig functions are given here. Now, if I want to write sine of x, I can do that. If I want to write 2 cosine of 2x, I can do that. Same thing with tangent. All right, everyone. So if we're going to do inverse trig functions, you'll simply see that we have these blue functions right here. Inverse sine, inverse cosine, and inverse tangent. Really simple. So we have inverse sine of x, for example. But what's really important is to not mistake this for cosecant, for example, because cosecant is the reciprocal of sine. So it might look like this is cosecant, but this is not. This is inverse sine, and it's really important to remember that these are the inverse functions. So I'll hit clear. But if you do want to write cosecant or cotangent or secant, then what we can do is we can simply write our function and raise it to the -1 power. That is our function. So if I just want to graph it, I hit the y equals, I hit clear, or I enter a new graph right here. So what would that be? That would be sine x to the -1. And now something that's also important for your graphs is you can scroll over. If you're hovering over this, you can enter it. You can change the color and you can change the stroke of your graph. I would leave it. I think it's perfectly fine. Unless you need some sort of special case with I don't know what, but anyways. But this is the really important part. If you only want to graph one of your functions and you don't want your calculator to take a long time, just hit enter on the equal sign. And if there's not a black square around a given equal sign, then that function will not be graphed. So I'll hit the graph button. And that is the cosecant function. This concludes our video on how to use the TI-84 plus CE. Mine is plus CE Python. I actually think the difference has something to do with coding, but I don't code, so essentially the same. If you enjoyed this video, please give it a thumbs up and subscribe. If you didn't, please share it with somebody else who will like it. And I hope you have a wonderful day.